Hello, welcome everyone. It's good to see so many of you here, even though I am the one standing in between you and lunch. So, I sometimes find myself in situations where I feel that I am too stupid to be a programmer. It could be days when I'm staring at the same bug for hours, when someone name dropped 3 frameworks I never heard of, or new version is out, I'm 4 versions behind, or maybe when I'm trying to figure out if I have something to talk about during a conference presentation, stuff like that. But using the word stupid is interesting because that indicates that in order to be a programmer, you must be intelligent. And that is maybe not wrong, but as I heard about the concept of fixed versus growth mindset from a professor named Carol Dweck, things align themselves for me. In short, if you have a fixed mindset, you believe that intelligence is a fixed trait. You are either intelligent enough to solve a problem or you aren't. But if you have a growth mindset, you believe that intelligence is a starting point. But in order to really succeed, you still need hard work and dedication, and that is how you evolve. And research has shown that if you have a growth mindset, you can recover from setback better, you handle confusion better, and also you're not afraid to take on new challenges. And these are all things that we need as a developer. And as I said, I sometimes feel that I am too stupid to be a programmer. I have a fixed mindset. And in order to help me get into more of a growth mindset, I try to look back at things I've done and see what I have learned, and that I actually have learned things continuously. And this is what we will do now also. And we will talk about 3 main things: integrating React and Backbone, project structure, and also a bit of unit testing. And my name is Therése Komstadius. I am a front-end consultant at Chas. I am currently assigned at PriceRunner. I have been working as a developer for about 2.5 years and mainly working with React. And this presentation might be a bit shorter, so we will have time after the presentation for questions. My first meeting with React was this: React Create Backbone class. And actually it's not really React, but it's a plugin to make integration with the library Backbone easier. And before we dive into this, I'm going to talk a bit about Backbone. And Backbone.js is a JavaScript library. It's built on the model view presentation pattern. The idea behind it is to help separate business logic from your UI in order to make changes easier. And in Backbone, we have models. And they are reusable objects that hold all the data and get synced with the server by a REST API. It holds getters and setters and everything else it needs to manipulate their data. And when something gets changed on the model, it will emit a change event. Here we have a small Backbone model. You have a method on it, set name, where you can change and set the name attribute on the model. And also, when you change the name, you might want to do something when you get the event. We also have views. And they are chunks of user interface. They are often connected to the models and listen for the change events so they can act upon them. And when a user interaction gets triggers in one view, it might make a model change its data, and the model will emit the change event, and all the views listening for that will get updated. So here we have a small view. The view listens for the click event from the DOM, and when the click happens, you might want to run a function that perhaps changes the toggle attribute on the model. And we also see that when the model changes, the view will call its own render. There are a lot of different ways to render objects from the views. You could use jQuery, and that is a soft dependency to Backbone, or you could use parsed HTML templates, or even React. There is a lot more to Backbone, but I won't go deeper than this. So the application where I first met React was a single-page application built with Backbone.js. It was a heavy, complex application, and it was sort of scary to change things because you never really know how a change might hit in the different places. The teams working with this application were mostly back-end developers, and I think that also helped contribute to the increase of complexity rather than decrease. Yeah, it's supposed to be like that. To the decrease, because the interest wasn't really there. We had also fallen into a lot of backbone pitfalls. We were modifying the DOM on arbitrary events. We were storing data outside the models, and also we were creating monolithic views. And these are all things that are easy to do when using jQuery, because it's perhaps more straightforward to hold all the state and all the data you feel that you are not ready to save yet right there and then, instead of going all the way around saving it. But it increases complexity, and it does not follow the backbone pattern. Like here we have a function that responds directly to the DOM event click, and it changes the DOM. And we also have a state variable sort of that's on the view instead of getting it from the model. And instead of only using jQuery, which was the initial approach of our application, we also started to use parsed HTML templates that got populated with data from our model. And it's very similar to server-side rendered HTML. And the library underscore, which is a dependency to Backbone.js, comes with a template method for us, so we could parse the text and create a template function that can get rendered with different data sources. In order to do that, we need to serialize the data, and that is what toJSON does for us here. So in this case, the model attribute name here would be rendered as the heading. When using jQuery, you manipulate the DOM directly. It's imperative programming. When an application has reached a certain size, this can lead to a lot of unexpected behavior and bugs. By choosing a more declarative approach, you would avoid the problem of not knowing whether a DOM element you would want to manipulate had already been manipulated or even removed from the DOM. And the HTML templates worked well for this, but we still had a lot of problem with re-rendering. And re-rendering the whole document, it took time, it made it harder for us to keep the state, and also it made the user experience a bit off. And since the DOM is really just a document, wouldn't it be nice if you could have something to handle the writing and manipulation of that document for you, instead of you doing it explicitly? And also without the performance hit of re-rendering the whole document all the time. Maybe we should use React. And React is also a JavaScript library from Facebook. It's inspired by functional programming, and it has a declarative approach to update the DOM. It builds a virtual DOM on render, and then it compares that to the existing DOM and only updates the difference. Another great thing about React is that it is components, so it's easy for you to build new complex things. In React, to describe what the UI is supposed to look like, we use JSX, and it's a syntax extension to JavaScript, but it reminds us a lot of HTML. When React sees an element that is user-defined, you can pass attributes with that component. And the child gets that as a single object called props, short for properties. And as of React version 14, these are immutable, so the child can only read it. You can see here we have a parent component that renders the child component with the attribute custom name. And the child would reach this by accessing this props and the attribute name. So the heading in this scenario would be Therése. The components also have a state that's fully private and controlled by the component, and when the state changes, the component re-renders. There's also lifecycle methods to make you hook in to different states in the component's lifecycle, like when it's mounting or unmounting. So we started introducing React into our application. And I think the idea behind using the React Backbone plugin was to make the transition smooth, because it would just tie the model to the component for us, and we could just add mix-ins with the ES5 syntax to the array in the component. But using this still made our connection to Backbone strong, and with that, all of our old concerns would still be there. By decoupling them a bit, we could start preparing for the future where we could introduce a more functional approach. We also wanted to start using ES6 syntax, and we also wanted to upgrade to the latest version of React. React 15 was just released at this time, and we were at React version 13. So we wanted to go to this, where we could use the ES6 class syntax, and with that, React component instead of React create class. And this React syntax did not have the ability to add mix-ins in the way we did before. We couldn't tie the model to our component either in that way, so we had to send it down using props. So this meant that there were two things we needed to do in order to move into this type of components instead, and that was to make sure that our model changes reached our components and also solve our use of mix-ins that we had. And tying the models to the components were not something we really wanted to do. Instead, we wanted to send new props and let React do what it does best, compare and update for us. And to do this, we needed to re-render the whole component. And because we had a lot of roots, and by roots, I mean the starter component trees that got rendered from Backbone views instead of an entire application that only had one root, that meant that we needed to re-render the components from those Backbone views. And the thing that we learned here was that we needed to call onMount component at node, because if we didn't do this, we got memory leakage because the old components would still be there when we were rendering new ones. We also had another solution that could force the React component to update on a model event using force update. And force update would trigger a whole re-render for the component and all of its children, but it's not really supposed to be called explicitly. It's better to just change the state or props and make the component update for you. But this is an escape we used. So both of these were not really solutions that we wanted to have in the long run, but it made our transition period easier. So what about the mix-ins? I was asking myself what a mix-in actually is, so I turned to Wikipedia. A mix-in is a class that contains method for use by other classes without having to be the parent class of those other classes, obviously. But in short, it's a way to share code in between objects without using inheritance. And for JavaScript, this means that it could be a regular object, a prototype, a function, or something else, and you could just merge the mix-ins into your own class, use it as your own without the ancestry. We had some mix-ins in our Backbone application, and adding them to the React component using the ES5 syntax was really easy. You could just add them to the mix-ins array on the component, and it would be in your context. But adding mix-ins in this way was an escape hatch from React with the initial adoption and learning of the library. The React team actually describes the use of mix-ins as problematic, and some reasons as to why is that it creates name clashes. You can't use the same name in different mix-ins or even components that uses a mix-in. It also introduces implicit dependency and increases the indirection of your application. Instead, they suggest using composition in some form. because it's components, as I said before, it's great for combining them to make even more complex ones. Yeah. On further investigation, we realized that most of our mixins were utility functions, so we could just break them out into modules and import them where we needed to use them. But for future use, we also introduced a composing pattern, higher order components, and it's a lot like higher order functions, which is a function that takes a function as an argument and returns a new function. But instead, it's a function that takes a component and returns a new component that renders the passed-in component. And that made it possible for us to add callbacks or other logic that different components needed, but still keeping it dry. And here we have the function composing. It takes a component and returns a new component where you could add logic and everything, and then it renders the passed-in one. These strategies made it possible for us to decouple a bit from Backbone and move our UI into React. Adding React to Backbone was not a pain-free experience, and I think a lot of that had to do with the state our application was in from the beginning, but also due to the fact that Backbone is made for mutable data. It wants to send specific updates when something changes, and React, in its more functional approach, they want the whole data model again and then do the comparison itself, and letting React do that is the strength with the library. So now that we moved into React, we wanted to think about how to organize our new components. What should our project structure look like, and how big should the components be? And to help us with that, we drew inspiration from atomic design. And atomic design, the idea behind it is that you can build design with the starting point atoms, like everything else in the world. And the atoms get combined into molecules, that gets combined into organisms, and in the end you have full pages. And the starting point, the atoms for this, it's the HTML tags. So for example, if we have two atoms, a checkbox and a label, we could combine them into a molecule, a labeled checkbox. And that molecule could be used in an organism, say perhaps a box to filter on different properties. And that organism could be part in a page with other organisms. And doing design this way helps you keep the objects you create reusable. And since everything in React, as I said before, are components, we were thinking that we could apply this atomic way of thinking to our application. When building new components or refactoring old ones, we tried to start with atoms that were close to the HTML object. So, for example, we had a button, and we could render a HTML button, but get the name of the button from our passed-in props. And also, when someone clicked on the button, instead of saying exactly what should happen, we could just call the callback passed in from the parent. And that would make our component reusable and able to handle different situations. And this molecule atom could then be used in molecules like forms and more things. And the thinking like this resulted in a tree structure that looked something like this. We had our components directory, and then we had 4 directories that were for each of the types. This was fine at first, but as more components were created, it got harder and harder to find what you were looking for. It was also harder to see how the components work together. And this might be fine if you knew what you were looking for and worked in these code base a lot, but that was not the case for everyone. And another thing that would become a problem for us was that we did not all have the same idea as to what was a component, a molecule, an organism. We didn't have clear guidelines, so it just sort of got different definitions from different people. And there were also people who didn't believe in this idea at all, so they just didn't do it. And this snowballed a lot for us. So in the end, it was like we were creating new components and putting them in a directory with a bit the feeling and a chance C. And upon refactoring, we also realized that UI objects that seemed similar had a lot of different underlying logic. So we could not really force them into the same component, and that resulted in a lot of specific components. So even the reusability idea behind it was a bit lost on us. We thought that a project structure that showed our relationship more between the components would benefit us more. So what we did was to make a directory for each top or root component, and also with that, a shared directory for components that all of our top root components shared in some sense. And from those top roots, we added directories for the direct children and the shared components for their shared, and so on. We kept going this way all the way down until we reached the bottom of the tree. And it resulted more in something like this. And here we can see we have company checkout and customer checkout that's in different directory. And they share a labeled checkbox and a labeled input, and they in their turn shares a label, and so on. And doing this might have been a bit verbose, but you could follow the components and actually see how a change in one might affect a lot of other ones. And the structure also made it possible for us to start introducing style and test files with the component. And having the style with the component could help us with the reusability idea, because that meant that we would actually style it on the component level and not decide it from the parent, which we had problems with before. And also having the test file in with it would give a better view as to which components were tested and not. It's easier to forget about them if you have them in a separate directory or a separate corresponding tree. So our more relationships showing structure might not be for everyone, but for us who had a lot of developers that didn't move in the front-end code bases on a regular basis, it helped a lot with the understanding. It was also helpful to be able to follow the tree and see where the data actually came from the beginning. And something I learned here was that you should really think about the project. Which state is it in? I mean, atomic design could be awesome if you're starting out with a new project, but it might not be a good thing to apply to an already existing one that you want to refactor. And just picking similar UI objects and forcing them into the same component might not really be the way to go. It could increase the complexity and the bugs of your application. Also, who are the developers working on this project? What are they comfortable with? Can you get away with a loose definition on things, or do you need clearer guidelines? Maybe it's better to compromise with a less dry approach if it will help with understanding and make people feel more comfortable and safe when they were making changes. And while we are talking about safe, I also want to talk about unit tests. Unit testing the UI is hard, and the simplest answer to why it's hard might be, what is your unit? In the example with our parsed HTML templates, what is our unit there, and how can you test the rendered output? We didn't have unit tests for our application, but we had Selenium tests, and Selenium tests are automatic web browser interaction. You write code that mimic user behavior, like logging in, filling out forms, and so on. But running them locally was something people didn't really do, because it takes a lot of time, and the different web drivers could behave differently in different environments. And also, people felt like writing them was harder than writing unit tests. It was more complex. But with React, we had an opportunity to start unit testing our UI. I've heard a lot of opinions about testing React. Some say that tests should only be written if they're worthwhile, and testing that data is displayed might not be the case. Some say that it's enough to test that something renders because that is what React does. And there are also people who say that you should test everything. I personally feel that tests makes you feel a bit more safe when changing things, especially when entering new code bases. It also helps you catch problems when you write a test, and it makes you really think about your code and what you wanted to achieve with it. It's the same as for unit testing the backend. But I think it's important to test the right things. And in the beginning, I was new to testing, so I would rather test the easy things than the right things. For example, I might test that a prop that was sent in when rendering could be found in the props of the component. Here I am using test-utils, which is a React add-on, to help me render the component. It renders the component with the attribute myProp, and then I expect the prop to be there. And this test is not really testing my component. It's almost rather like it's testing React, and that it does what I expect it to do. It doesn't really give me anything. It's almost like I don't even test that something is being rendered. A thing that might have been more valuable to test could be something that might depend on a prop. Here we could imagine that we have a component that renders a div based on a prop's true or false value. It will render the component with showDivTrue, and then we will try to find the rendered component and expect the found one to have a class name that we want. So from testing the easy things, I started to look at the component that I wanted to test and break it down to things it was actually doing. Was it rendering something? Was it changing its behavior based on props or state? Or was it responding to user interaction and so on? Writing tests help me to evaluate if my components are behaving the way I want them to, and to really think about my code. And I think that this is a gain beyond just testing your application. In time, we got new tools to help us with our testing, like Enzyme, the library from Airbnb, it's a library that's built on the test-utils, but it gives us a more intuitive way to assert, manipulate, and traverse our component output, like the find the render DOM component with tag from the example before would be just find using Enzyme. And also just the test runner from Facebook, that's super easy to set up and comes with almost everything you need, like spice mocks and assertions. And they also make it easy for you to use snapshot testing if you don't want to write unit tests for everything. And snapshot test is a test that compares your output to a saved snapshot of what it should look like to see that you keep your state. And tools like this makes the testing experience rather pleasant, I think. But actually getting into the best way to test your component feels like an endless subject, so I won't get into that. But my point here is that with React, you do have the ability to unit test your UI. Doing things the best way, or the right way, and on the first try, is things I get stuck with a lot. And if I do it wrong, then again, it must indicate that I am stupid. But looking back in the way we did now makes me realize that things are almost never done the right way from the beginning, or even the 10th time. But it's not for nothing, because with it all comes experience and knowledge and an insight that sometimes things goes badly and things are really confusing and new challenges are almost always around the corner. These insights that a growth mindset gives you and that you need as a developer. Also, investigating why we change things can help a team with its work process and also make you better understand why new things pop up all the time. Instead of only feeling fatigue of yet another update, you could scratch the surface and see the gain that comes with it. For example, React version 16 came with a very few rewrite for the user, but underneath, the whole core algorithm was rewritten, called Fiber. And it was rewritten to help the render performance. And with that rewrite, it also opens up for new features in future releases, like async rendering without blocking the main thread for a better user experience. And things like that one can really make me feel more excited instead of only feeling stressed. And that is why I think that we should all just keep on growing. Thank you.